Hi, I'm Jason with Gardner, Benner, and Sperry Instruments Technical Support Department. And I'm going to be going over non-contact voltage testing. Here we have our new 2-in-1 non-contact voltage tester, which also has a built-in GFCI/circuit tester built into it. Now, how this works is you hold down the button. While holding it down, it beeps once, which tells you that it's good and the battery is good. You continue to hold it down, and you put it towards an electrical source, and it tells you that there's voltage there, both visually and audibly. Now, the way that these work is your body completes the circuit. So, when sensing for voltage, if the conditions differ, whether that's the conditions in a room, the application, or how the circuit was wired and constructed, the material involved, this can all change the outcome of what you're actually looking for. So in this instance, you have bare wire. Now what's happening is that when you have an electrical signal going through this wire, it's emitting a small magnetic field, small field of electricity. So when I go to turn this off, and I use a non-contact voltage tester, I don't get anything here, but we know that voltage is in the socket here. So I have to go all the way in to get the non-contact voltage sensor to go off. Now, what that tells me is that when the circuit's turned on, it's emitting a much larger field than it is when the circuit's turned off. Now, what can happen in your home or on a job site is that if you have bare wires like this, or depending on how your circuit is wired, you might have a much larger magnetic field. And what happens is if there's a lot of moisture in the air or static electricity, the voltage sensor might go off a lot more. Also depending on maybe what you're wearing, the shoes, the type of sole that you have. Again, your body is completing this circuit. Now, material is also a big part of the equation too. If you have an electrical circuit like this, an outlet box, where everything's plastic and it's grounded correctly, it's going to emit a little bit bigger of a signal than it would if it was a metal box and it was grounded correctly. Now, if either of the circuits aren't grounded correctly, you're not going to get a small signal, you're going to get a larger signal. That, again, it depends on how it's wired as well. So there's all these variables that play into this. Now, one of the cool things about a standard non-contact voltage tester in your body completing the circuit is that if I turn the circuit back on, that large field is going to be present again. You put your finger towards the front of the tester, like I am here, turn it on, and depending on where I put my finger, it reduces the sensitivity of the non-contact voltage sensor. Now, another thing that you can do, but more of a pro item, would be the VD6505. The VD6505 is a standard non-contact voltage sensor, but it also has a sensitivity dial on it. So if I turn the sensitivity all the way up, and I hold it on, I can sense voltage anywhere. And that's what a lot of people are seeing. So with this tester, the nice thing about it is I can turn that sensitivity all the way down, and then I can detect which wire is hot, which would come in handy if, say, you were working on a light fixture and all of the wires were painted white. And you needed to figure out which was the actual line voltage coming in from your circuit breaker. Now, if you have any questions, feel free to give us a call or shoot us an email at tech.support@gardnerbender.com. Thanks for watching.